In this demonstration video I'm going to show you how the Gertbot deals with error signals. Every Gertbot has 4 H-bridges and each H-bridge has an error signal coming out of it. The error signal is activated if either very high current is detected or if the chip is very hot. The error signal is connected to the enable of that channel, so always when an error appears, that channel is disabled. Additionally, the error signal goes to the microcontroller, which can be programmed to respond to it in various ways. We've seen that in an earlier video where I tried to start a brushed motor and nothing happens because the inrush current stops it. What we did then is we went to the extra settings and changed the uptime to slowly start the motor up. There's another way of dealing with this if we make sure the short circuit signal, the error signal, is ignored by the microcontroller. Now if I start the motor, it starts. What's happening but not immediately visible is that the error is still appearing. There's a high current and the motor channel is disabled for a short period of time. However, the microcontroller doesn't respond to the error. Because the channel is disabled, the high current goes away, so the error signal disappears again and the high current appears again. In fact, what's happening is that the enabled signal is oscillating for a very short period of time, but it gives enough energy for the motor to start. Now that happens so fast that when I do start the motor, you don't notice it. However, there is a situation which you can force this for a longer period of time. If I switch from full forward to full reverse, the short circuit is present for a longer time and you can hear the circuit responding. That little squeal you hear is the short circuit oscillating for a longer period of time and giving enough energy for the motor to start. So at the moment the microcontroller is told to ignore the error. However, I can do more modes. I can stop its own channel, I can also stop its adjacent channel, which I'm going to demonstrate now. We're going to start the second motor. I'm going to start this motor first. And now I'm going to set, if you see an error, stop motor 0 and 1. Going back, and I'm going to switch motor 0 to full reverse. And as you see, both motors stop. There's another mode in here which you can stop 0 to 3. That means that if an error appears, it stops all motors of the same board. At the moment I cannot demonstrate that because I haven't got any motors connected to the other 2 channels. There's a last mode, is stop all. What happens is if one of the channel which has this mode set sees an error, it pulls the hold signal and all the boards get the hold signal and all the processes are stopped. I can show that by going to board 1, start the stepper motors. Here I have to make sure that we do not stop when I start motor 1. Start this one. Now if I switch to stop all, for the demonstration, if I switch motor 1 full reverse, it gets a very high current and the error signal is passed to the microcontroller, which stops all motors. This is extremely useful if you have a complex system with multiple motors, like a rap. If one of the motors fails, you can stop all the multiple motors at the same time. Means your system is stopped in that situation. You don't have to worry that half of your motors are still running and the other half is stopped, causing real havoc.